Let's just dive right in. I mean, think about it. Artificial intelligence is absolutely everywhere. It's in our search engines. It's suggesting what we should buy next. It's even helping us write our emails. But how much do we really get what's going on inside these incredibly powerful tools? Today, we're going to look at a whole new way to understand AI. Not by taking apart the finished product, but by watching it evolve.
So here's the big problem, right? We're using models like ChatGPT all day, every day, and they can do some amazing things. But the second we try to pop the hood and see how it works, it's just this deep, complicated mystery. It's kind of like having a super genius who can solve any problem you throw at them, but they have no way of explaining their own thought process. And for the people building this stuff, well, that's a really unsatisfying and kind of scary place to be.
And that brings us to our guide on this journey, Naomi Saphra, a researcher over at Harvard. And her whole argument is simple, but it is so profound. She says that to really, truly understand an AI, you can't just look at it when it's done. You have to go all the way back to the beginning. You have to understand its origins. And believe me, this one idea might just change how we look at this entire field.
All right, so before we get into Saphra's big idea, let's just take a second to appreciate the sheer scale of the mystery we're dealing with here. As Saphra says, flat out, we don't know what makes a language model tick. This has created a whole new field of science called interpretability. You can think of these folks as like digital neuroscientists. They're trying to peek inside the AI's black box to map everything out. But here's the catch, and it's a big one. What if just looking at the fully grown brain isn't telling you the whole story?
Okay, so if dissecting the finished product isn't enough, then what's the alternative? Well, this is where Saphra's approach takes this brilliant turn, because she pulls her inspiration from a totally different field of science.
Now this right here, this is the aha moment. This is Saphra taking a super famous quote from Evolutionary biology. The original was, "Nothing in biology makes sense except in the light of evolution." By swapping out evolution for something called stochastic gradient descent, she's making a huge claim. She's saying the training process itself is to AI what evolution is to life. It's the one force that shapes absolutely everything. So what on earth is stochastic gradient descent? Don't worry, the name is way more complicated than the idea. Basically, it's the algorithm that teaches the AI. Just picture a teacher making trillions, and I mean trillions, of tiny little corrections to a student's work over and over again until that student, the AI, starts to see the patterns in a giant sea of data.
So let's just break that process down. An AI model, it starts as a total mess, just a random jumble of connections between these things we call artificial neurons. Then you give it a simple task, like, hey, try to predict the next word in this sentence. And at first, it gets it wrong, a lot. But each time it's wrong, that training algorithm makes a tiny little tweak. Now you do that trillions of times, and something kind of magical starts to happen. These complex internal structures begin to form, and that's what allows the model to actually understand language.
Now that whole process sounds pretty straightforward, right? But here's the twist. If we only look at the AI after it's fully trained, we might be getting fooled by what Saphra calls ghosts in the machine. Things that look super important, but really they're not. Think of it like this. You know how in human evolution we have things like an appendix or wisdom teeth? They're basically leftovers from our evolutionary past that don't really do anything important anymore. Well, Saphra's arguing that AIs might have the exact same thing, structures inside them that look critical but are really just remnants from an earlier stage of their training. And this cat neuron story just illustrates the point perfectly. So picture this. Researchers are studying an AI, and they find this one neuron that just lights up like a Christmas tree anytime it sees a picture of a cat. So the obvious conclusion is, wow, we found the cat neuron. This thing must be essential. But then they tried something wild. They went back and trained a new model, but this time they blocked that specific neuron from ever developing. And the result? The AI actually got better at identifying cats. That so-called cat neuron was holding it back. It was a ghost, a vestigial feature.
Now, this really unique perspective on AI didn't just come out of nowhere. It actually grew out of Saphra's own personal journey, a story where a major limitation actually became the source of a huge innovation.
Just imagine that for a second. You're a PhD student in computer science, a field that runs on coding and speed, and all of a sudden you can't type. You can't even write by hand. This was the incredible challenge Saphra was up against. She had to find a whole new way to work, literally dictating her code.
So she knew she couldn't compete in what she called the race to the scoop. She had to play a different game. So instead, she pivoted. She decided to focus on this kind of weird niche topic that pretty much nobody else cared about.
the actual dynamics of the AI training process itself. And that constraint, that limitation, it forced her down a path that would become her life's work.
And this little crocheted octopus is more than just a cute gift from a student she was mentoring. It's really a small symbol of the human connection and the very unique path that's defined her career. It represents a different kind of progress, one that isn't just about being the fastest.
And that's really the lesson she took away from all this. By being forced to work on a slower, more deliberate schedule, she completely avoided getting sucked into all the latest hype waves in the industry. It gave her the space to think deeply and come up with something truly original.
Okay, so let's tie her personal story and her scientific breakthrough together. Why is this evolutionary view she's pioneered so unbelievably critical for the future of AI?
This chart really just sums it all up. The standard way of doing things is to look at a finished AI and ask, how does it work? It's like dissecting a fully grown animal. Saphra's method, on the other hand, watches the whole process, from embryo to adult, and asks why it works that way. It's a fundamental shift, and it lets you avoid getting fooled by those vestigial parts, because you can actually see when a new structure appears and whether it's actually linked to a new skill.
So the crucial thing here is what you could call the AI's fossil record. By saving checkpoints all throughout training, and by comparing lots of different training runs, you can start to see which structures pop up again and again and are truly connected to specific behaviors. You're not just finding a correlation at the end, you are literally watching cause and effect unfold over time. And that is much, much stronger evidence for how these things actually learn.
You know, when you get right down to it, Saphra's work is asking us to think of an AI's training not just as some technical process, but as its childhood. It's that formative time where all its abilities, its quirks, maybe even its hidden biases are all born. And it just leaves you with this one big question. What other secrets are hiding in their past?